All right, to classify conics by just looking at their equations. We have not done parabolas, but we're doing those today. That's not going to matter when we classify conics because parabolas are different than the other three conics. The three conics that we've talked about so far are circles, ellipses, and hyperbolas. And in the equations for circles, ellipses, and hyperbolas, they both have x squared and y squared. What's the difference between circles, ellipses, or hyperbolas with the x squared and the y squared? In the equations, there's something different. There's what? Subtraction, right? The hyperbolas have subtraction, where the ellipses and circles are addition in between the x and y squareds. So if you see an x squared and a y squared and a subtraction in between, you're going to know that's a hyperbola. If I have plus, how would I be able to tell if it's a circle or an ellipse? Gracie?
Ellipse is equal to 1.
So if you look ahead, they're not going to be in that format. So if it's in that format, sure. But what if it's not in that format? What could I use about, let's just look at number 1. Let's just like dive right in. Which conic is this got to be? Hyperbola. Why? Hyperbola. Hyperbola because we've got the x squared, we've got the y squared, and one of them is negative. So it's got to be a hyperbola. But how about the second one? Who said circle? Does that matter? Why?
Oh, wait, does that not matter?
No, it does matter. It's not in that form, so I'm not going to call them A and B. But the stretch on the x and the y squared are the same. So when we talk about making that circle and like stretching it horizontally or vertically, it's going to be the same stretch. So definitely a circle. Okay, so that's how we can tell it's a circle there. Now for number 3, I only see an x squared. I don't see a y squared. So this would be the one we haven't talked about yet, which is parabola. Now we should already know parabola equations from past courses. So I figured we could look at this and figure it out still. Number 4. Can I have a volunteer? Don't yell out. Can I have a volunteer tell me what they're thinking? Lainey?
Is it an ellipse?
It is an ellipse. Why do you think that?
You can take the negative x and y and you can like divide it by a negative 1.
So why is it not a circle?
Because it's over,
I don't know what it's going to be over because I'm not solving it, but you can look just at these numbers right here and they're being stretched by different amounts. Okay, so you can just look at those numbers. They're being stretched by different amounts. So one of them is going to be longer. It will be an ellipse. Okay, can I have somebody different for number 5? I think give away somebody new. Or I'll just call on you if we have too many bashful people in here. Christopher. Did you say a hyperbola? And why? They're different signs. Different signs. Yeah. Okay, how about a volunteer for 6? Gavin? Yep. Can you tell me why you thought? Oops. Right. Oh my gosh, why can't I spell? I just did the same mistake twice. Yes, so if I multiply everything by -1 or divide everything by -1, I'll have a positive x squared and a positive y squared. So we're talking about the closed figure, and then they both have a 1 in front of them. So there's no, I mean, the stretch is going to be the same, so circle. Okay, a different volunteer for number 7. Or I'll just pick you. Nobody volunteers. Megan. So this one, hyperbola, this one is in the format that we're used to. Yay. Number 8. Barry? This one is an ellipse. Good. Number 9. Somebody new? Or I'll just pick you. Ryan. Ellipse is correct. Why do you think that? So it's positive, and then how do we know it's not a circle? They don't have the same coefficient. Okay. We're going to actually come back to this one when we're done. So number 10. Volunteer, please. Sanjay. Circle is correct, but it's not in the correct form. It says equals 1. Okay, well, we can make it in the correct form, and then it wouldn't say equals 1 anymore, right? All right, 11. Marie. Ellipse, why? Okay. And the sign is positive, good. And 12. Tyler. Circle, why?
Because you can divide the -3 by, you can divide both by -3 to get 1.
Okay. Or we could divide by -1. -3 is fine too, but it doesn't even matter. They have the same number in front. If I want to just rewrite this as -3x squared plus -3x or 3y squared, they have the same number in front, okay? And they have the same sign. So definitely circle. And number 13, Jack. Parabola is correct. Why? Perfect. There's a y squared, but there isn't an x squared. And 14, Abigail. A little bit louder, hon. Hyperbola, why? Because there's negative in between the x and the y squared. Good. All right, let's go back to what I say, number 9. Can you guys put that into the correct format? Like the ellipse form? Can you write that equation in the standard graphing form? So if it's an ellipse, it needs to say equals 1, right? Yes, thanks. Okay, so I am putting this into the standard graphing form, and I get -2x squared minus y squared over 10 equals -1. Okay, I can also look at this as being like x squared over -1/2 squared minus, plus y squared over -10. I don't know why I wrote squared there. That's not a squared. That would just be -1/2, sorry. equals 1. So I just took that negative sign and I gave it to the denominator instead of outside of the fraction itself. I also undid this since we have a number on top. I flipped it and I divided by the number instead of multiplying by -2. We're dividing by -1/2. So what's my A and B value? When I go to graph this, Ava, what would my A or B value be when I go to graph this? This is A squared or B squared. Which one? This, I don't know which one. This one, I don't even know what's bigger. It doesn't matter which one's bigger, but. Oh, what is the square root of -1/2? Okay, all I heard was I. That's not really all I heard, but that's all I heard that was important. What's that mean? So when I go to plot I know we know how to do it, but let's think about it on the XY axis. We know how to do it on an imaginary and real axis, but on an XY axis, how do you plot an I? On a real axis, how do you plot an I? You can't, okay? Oh, I had this one graphed earlier. I must have closed it. If we graph this one, what was the question? 20, what was it? Did I just close this? Oh, did I? Oh, it went on this one. Okay, I'll do that. Plus y squared plus 10, thank you, equals 0. So when I graph it, you won't even see anything there because it doesn't make anything. So good, it went back. Hopefully it saved where I was. Yeah. So we were able to put it kind of into that form, but it's not actually an ellipse. I just want to point out to you, just because you see an equation doesn't mean that it's going to automatically be one of those things. This is the only one that didn't work. I'm not giving you any in homework that don't work, okay? But I want you to be aware, just because it kind of looks like it would be an ellipse, that doesn't mean it actually would make an ellipse, okay? It's got to satisfy all the conditions, including when we set it equal to 1, we're going to need positives over here so that we can square root them. That's all. So that is the end of the first section of notes. In your homework, you will, choose what it is. And there's also a couple review questions in there. I threw some graphing questions in there just because we have a test this week, just to make sure that we are prepared for that test. Okay, so you'll have some hyperbola graphs just to review to begin with. All right, the other section is 10.2. And we're going to talk about parabolas. I tried to draw this in my first class and it was bad. So I'm just using one from the internet real fast. Okay, one thing you're going to notice about this parabola is that it opens to the right, but it doesn't matter which way. Doesn't matter which way it opens. The definition of a parabola would be the set of all points that are equidistant from a fixed point, and that's our focus, to a line which we're going to call the directrix. They're equidistant at every single point. The points on the parabola are equidistant between the focus and this directrix at every single point. That's how a parabola is formed. You guys know how a circle is formed, right? It's all the same distances around a fixed point. So this is same distance between a fixed point and a line. That's how we get our parabola. There is a video on constructing a parabola, like with compass, no, protractor, straight edge. I forgot to upload it, but I'll upload it later in this class if you want to go and watch that video on how you would construct it using the geometry tools. Anyway, excuse me. Go to another picture here. The focus, ooh. I was trying to find one with the variables that we use. Maybe this one. You guys did this last year, by the way. So this is review. Okay, you saw how fast I could find this information that's on the internet. Everything's on the internet. Hear that, Patrick? How can you hear with a headphone in your ear? Take it out. Take it out. Okay, in the equations, which you can see on your set of notes, here's one of the equations. We've got two sets of equations. Here's one of them right here. There's this p-value in there. The p-value is how we get our focus. Right here, you can see that H and K is the vertex, which we should already know is that part of the parabola. And then to get the focus, you're going to add P. To get this directrix, you're going to subtract P. There's information right there. We're going to do it live. There's also something called a lattice rectum. The lattice rectum helps you stretch how far out the parabola will be from the focus. The lattice rectum connects to the focus, and each side of that lattice rectum is 2p long. So once you find the p-value and you multiply by 2, you're going to add or subtract 2p to find the ends of the lattice rectum. Here it says lattice rectum is 4p in length, but each piece is 2p. All right. We're not going to do every single question in the notes. The first two are just like have no... Oh, I didn't go over this part yet. The first two we're going to skip. Opens up or down, opens left or right. If you have a p-value that's negative, that's either going to be left or down. Okay. If you have a p-value that's positive, it's either going to be up or right. We're talking about the two positives or the two negatives. How you can tell if it opens up or down would be when you think back to the parabolas that we almost always, I didn't write that correctly, that we tend to graph the most of. We tend to graph the most of the ones that are x squareds, and those open up or down. Those are functions. We can write it as f of x. The ones that open left or right can't be written as functions because those are like x equals y squared kind. They cannot be written as functions. They're the ones that would fail that vertical line test. So I think about the functions and how I normally write it to know which one's which. They're almost exactly the same format. It's just one of them has the x squared, one of them has the y squared. Everything's right there that you need it, but you're not going to have that on the test. I'm skipping 1 and 2 because those are just super easy. We're going to start at C, or it's not 1 and 2. It's A and B. We'll start at C. So the first thing we want to do is have it in the correct format, which this is not. It involves completing the square. So we look at which variable do we need to complete the square with. X. We don't have to do it with y because only one of them is squared. So x squared minus 6x, I'm going to complete that square with something, equals 4y minus 29 plus that same something. So what goes in the box? Philip. Good. So that means 9 goes to the other side as well. So we'll have x minus 3 squared equals 4y minus 20. Now, to be in the actual format of the formula, you will notice that for both of, it doesn't matter which one I'm looking at, but for both of these, the variable inside of the parenthesis is just that variable with a coefficient of 1. That means whatever's in front of the y or whatever's in front of the x, I have to factor it out. So for this one, I'm going to be factoring out 4. Doesn't matter what this number is, I got to factor it out so that it's all in front. And we'll have y minus 5 left over. So this is in the correct format. Our vertex will be HK, and it's just like doing the circles or the ellipses or the hyperbolas. It's going to be the opposite of each of those. Just make sure you put the X part first, 3, 5. To figure out which way it opens, we look at this number right here, and we can actually find P first if we want to. But I can look at this and know which way it opens before I even find P. It's positive. So my choices are either up or left, or right, sorry, up or right. So then I also look at the equation and I notice that x is the one that is squared. The one that's squared, no, the one that is by itself is the direction it's going to go. So this is, so the one that's by itself, not squared, the one that's to the first power would be the y. So that's telling me it's going to be up. To find your p-value, the number that is in front of the parenthesis, we set equal to the formula that says 4p goes there. So 4p is 4. What does p have to be? 1. Let me graph what I have so far. 3, 5. It opens up. So one thing I'm going to throw in there that isn't in this list of stuff is your axis of symmetry. And I'm putting it in there because if we find other points, we know they mirror around this line. So I just graphed my axis of symmetry real fast for fun. Okay, the focal point, because it is opening up, our focal point is going to change on the y values. So I'm starting at my vertex 3, 5, and I'm going to use my p-value to add to the y value. So we'll have 3, 6. Visually, I can go over to the graph and go 1 up and find that ordered pair. The directrix is from 3, 5. We're going to go the opposite direction as p, so I'll go -1, and it's going to affect y. But this is an equation. It is a line. So the number that changes is the variable that I use in my line. It's the number that changes. The 3 is the same for all of them. So y equals 4 is my directrix. The latus rectum, we do 2 times p, which is 2 times 1, which is 2. And we're going to add and subtract that to the focus. It's out from the focus. So I could graph it and just figure out those ordered pairs, but I was going to go over it with the ordered pairs as well. So our focus is at 3, 6. since the P value, I'm sorry, the directrix and focus were up and down, the latus rectum is going to go the other direction. So this is going to be left or right. So I'm going to plus or minus 2 from the X. So my endpoints, this is going to be the endpoints. My endpoints of the latus rectum will be at 1, 6 and 5, 6. Or we could just go on the graph and count from the focus out, and it would be at 1, 6 and 5, 6. Okay, there is some other information that we typically find when we do graphs, and it's not something that you're have to fill in, but we're going to go over because it's important. What do we always find when we do graphs? Always. Seems like it always. Somebody's talking but can't tell who. We do find domain and range. I'm not going to ask that one yet. Find something else just about the actual like ordered pairs on the graph. There's some other ordered pairs I'm going to find. Intercepts. Yeah. So how about x-intercepts? How do we find those? How do we find them? I didn't ask what they were. What about 0? Oh, is that you? I can't tell who's talking. Make y 0, and then you solve to find the x-intercepts. But somebody was like, there aren't any. Because you guys, if it opens up and it starts way up there, we're not going to have any for this one. What about the y-intercept? Make x equals 0. So let's find the y-intercept. I'm going to always go back to the original just in case I made a mistake. 0 equals 4. It's got like 7 1/4. And if I have 7 1/4 for my y-intercept, that axis of symmetry actually allows me to find a mirror point to the y-intercept. That's pretty good. Should be able to graph accurately. If you got a y-intercept and it did not look like it flowed on your graph, maybe you made a mistake somewhere in your work. So that's why I always go back to the original, because it's pretty easy to find your y-intercept. Good? Let's do another one. So not in the correct form, got to make it in the correct form. What are we going to complete the square with? Can't hear you. The y. So we're going to do y squared plus 2y plus 1 equals negative 10x plus 9 plus 1. So y plus 1 squared equals negative 10x plus 10. So at this point, you have to have a parenthesis on the x side. X has to have a coefficient of 1, so I have to factor out negative 10. So Sam, where's my vertex? What'd you say, Sam?
I did this before, and I didn't do the x-intercept.
I'm asking for the vertex for D. 1, negative 1 is correct. Just if you got negative 1, 1, please make sure that you're putting the x value first because it's in the other order. It's fine if you're working ahead, but if you've already done it, then you should be able to answer me, right? Okay. I talk slow. we got to figure out which way it opens. So we look and we see a y squared. Typically, we don't do equations with y squared. So this is the left-right kind. And then I look at my negative 10, which is a negative. So this is going to open to the left. What's wrong, Tyler?
Never mind. I see it.
Okay.
The thing was -1, -1.
Gotcha. You didn't factor out the negative all the way?
Yep.
Yeah, gotcha. All right. So now we're going to find our p-value. We're going to set -10 equal to 4p. So this number that we factored out, we set equal to 4p. And Emily, what am I going to get?
Sorry.
So we got a -5/2, which again is telling us that it's opening to the left. So my focal point, since it's opening to the left, we're going to take our vertex and we're going to add -5/2 to the x value. So that would be -3/2, -1. Then we have to do the opposite for the directrix. We're going to take the 1 and we're going to add 5/2. And then what we're changing is the variable that we're going to use for the directrix. So we're changing the x's and we'll get 7/2. X equals 7/2 will be my directrix. The latus rectum is 2 times the p-value. And it's absolute value, so it doesn't even matter if I put -5/2 or 5/2 in there. It doesn't matter. So I get 5. And we're going to do plus or minus. And that goes the opposite direction as the focus and the directrix. So, and it also goes off of the focus. So I'm going to have -3/2, -1, which is my focus. And then I'm going to add or subtract the 5 to the y of that. So I'm -3/2, -6, and -3/2, +4. Or, like I said earlier, you can just go to your graph and count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So now let's talk about extra information that we should, as a student of honors pre-calculus, be able to find. What kind of information should we be able to find? Will we have an x-intercept? How many? Since it's opening to the side, we're only going to have one x-intercept. Let's see if we can find it. Question? No? So finding the x-intercept, you make y 0? Yeah. So we'll have 0 plus 0, 10x minus 9 equals 0. So 10x equals 9. X is 9/10. So the x-intercept will be at 9/10. And I'm going to graph it. There is I didn't graph it yet, but there is a axis of symmetry that goes in the middle of this parabola. So I can also graph a mirror point to that 9/10. And those look right. They look like they're in the right place. How about y-intercept or y-intercepts? Are we going to have any? looks like it should cross the y-axis. So for this one, I would actually go to this step here to find my y. Because if I was using the original, I'd still have to do what is done on that one. I guess you could use quadratic formula too. But so the y-intercept we make x 0. So we'll have y plus 1 squared equals 10. We'll square root both sides. And then subtract 1. We get y equals -1 plus or minus square root 10. Square root of 10, what is that? 3.2? It's right over 3. I mean, how accurate can I really draw it? So that would be at like 2.2. That looks good. And then mirror that at -4.2. That looks pretty good. Ugh, that was a terrible graph. You guys got questions on this stuff? The reason why I'm throwing the x-intercepts and y-intercepts in there, just when we take our test, I'm going to tell you right now, it's the last day of the quarter. I'm not going to have you actually physically graph anything like I've done in the past, you know. I'm not going to have you do that. I'm going to have you answer questions about it. And one of the questions might be, what's the x-intercept? So you should be able to find it, okay? So you should be practicing that. And I'm pretty sure in my answers I have, maybe I don't. I'm pretty sure I do, though. Have some x-intercepts or y-intercepts in there. Maybe I don't. Anyway, make sure you practice those. All right, and then the last section, if you guys know how to do this, you're more than welcome to ignore me and start working on the assignment. I'm doing this because I'm making a video. I am going to do all 3 of these. So you're going to find the equation of parabola that satisfies the given information. I'm a visual person, so I like to see it. -4, 2. And that's my focus. And then my directrix is x equals -6. So just looking at that, I can find my vertex and I can tell which way it opens because of where the focus and the directrix are. So my vertex will be, it's going to keep the same y value. And it's going to be exactly in between -4 and -6 for the x, so -5. It opens to the right, so that's going to be a y-squared kind. The p-value is going to be how far apart the vertex from each focus or directrix is, which is 1. So then I use the equation, y minus k squared equals 4p times x minus h. So y minus 2 squared equals, then I do 4 times 1, and then x plus 5. So that would be my equation. Question B is really similar to the first, to question A. So the focus is at 6, 2, 2. And the directrix is y equals 3. So that's going to tell me that my vertex is right in the middle of that, and it should open down. So my vertex will keep the same x value, but the y value is going to be exactly in between 2 and 3, so 2.5 or 5 halves. Since it opens down, my p is going to be negative, and then I figure out how far apart the p is from the focus. Sorry, I said that wrong. The vertex from the focus is 1/2. and this opens down. So it's going to be x squared. So x minus 6 squared equals, I'm going to do p times 4, or 4p, sorry. 4 times negative a half is negative 2. And then y minus 5 halves. Done. All right, and then C says the vertex is at 3, 4. And the focus is at 3, 7. So I can tell that this will open up. So I know it's x squared. My p-value's got to be positive. P-value is how far the focus from the vertex is, which is 3. And they already gave me the vertex. So x minus 3 squared equals 3 times, nope, not 3. What'd I do wrong there? Who's paying attention? Yeah, that has to be 4p. So 12, and then y minus 4. Okay, and then you'll need just a few graphs for that. Remember, I have graph paper on the modules if you need some.